Hey everybody, this is Mrs. Cooner back with the lesson on base 10. So what we already went over is what base 10 means, right? So it's the place values, all 10 to the 0, 1, 2, 3, and onward. And then we went over some lattice addition and how it's actually the same thing as our normal addition. It just helps us kind of know what's going on with those place values. So I told you I'd be back, and now we did addition for our arithmetic in base 10, and now we're going to do some multiplication in base 10. So we're also going to start with the lattice method. I'll bring this up to keep our colors for the different place values. So we're going to talk about the lattice method to do the example of multiplying 100, we'll do 124 times 256. We'll be multiplying those two together. So that's going to be our big overarching question. So what we're going to do is we're going to use this box again to keep our places straight, in the same way that we used these boxes to keep our places straight for addition. So it should look pretty similar. So we're going to do 100, 100, so I do that in orange because that represents our hundreds place. 20, 2 in the tens place, 20, 2 times 10 is 20, and then 4 in the ones place. And then times 256, so 256. Sweet. So before we get into here, because I'm going to be using a lot of different colors to represent different place values, I want to talk about how I know what place values are going to go in which box. So over here I have a box with just our arbitrary ones place, tens place, hundreds place, hundreds place, tens place, ones place to write our numbers out. And again, I just picked a 3x3 square to 3-digit numbers. You could pick a 4x2-digit number, like a 4-digit number multiplied by a 2-digit number. You could pick any different size number you want and still be able to do this lattice, as long as you make each side long enough to fit that number, which is a super cool way that we can do any multiplication we want. So let's talk about what place value is going to go where in this. So let's just talk about this box right here. So in the upper right hand corner we have the hundreds times ones. So what's the smallest thing we could possibly get? The smallest thing we could possibly get is hundreds, right? And then what happens if we get 10 of those hundreds when we multiply? If we get a group of 10, 10 times 100 is 1,000. So we could have thousands up here. In the same way we did our addition over here, right? And when we had a group of 10 ones, we got hundreds. When we had a group of 10 hundreds, we bumped it up to 1,000. Here we have hundreds, but when we have a group of 10, we're going to bump it up to the thousands. So similarly, we have ones times tens. What's the smallest thing we could possibly get? 10 times 1, we could get in the tens place. And if we get a group of 10 of those, 10 tens will bump us up into the hundreds place. I think you might be starting to see the pattern a little bit. And then if we have 1 times 1, the smallest thing we can get is 1. So I'll be pink for our ones place. And then if we get a group of 10 of those, that will bump us right up to the tens. So now let's do the next row. So here we have tens times hundreds. So the smallest thing we could get is thousands. And then if we have a group of 10,000s, that's going to bump us up to 10,000. So up here would be our rollover for 10,000. And then similarly, 10 times 10, the smallest thing we could get is 100. And then if we get a group of 10 hundreds, that's the same thing as 1,000. Down here, 10 times 1, the smallest thing we could get is tens. And if we get a group of 10 tens, 10 times 10 is 100. So that'll bump us up to the hundreds. So this is kind of just the place value of the numbers we're going to go in. And if you see the pattern, we'll do one more just in case you didn't get it. Hundreds times hundreds, the smallest thing we're going to get is 10,000s. And then if we have a group of 10 10,000s, that would bump us up to 100,000s. So do you see how they're all going along the row? Just in the same way, kind of in our addition, it lined up for when we added to go along the same color row. It's going to add up in our lattice multiplication as well. We're going to have the same colors going down the row. So this is the pattern. And then just to double check that I'm not crazy, ones times 100s, the smallest thing I could possibly get is hundreds, and if I get a group of 10 hundreds, that will bump us right up to the thousands. Sweet. And then we'll explain more of why these colors are going to be while we're doing our multiplication. So let's again start in this upper right hand corner, just because it seems nice. You can really start wherever you want because each of these boxes is going to operate independently of the other. So right here we have 4 ones. 4 ones times 2 in the hundreds place, right? So times 200 is going to equal 800, right? So we're still in the hundreds. 800, which is the same thing as 0 thousands plus 8 hundreds. So here we have 8, 0. Sweet. And we could have also just looked at this independently and said, oh, 4 times 2 is 8 with 0 to carry over. So now let's go do this row. So we have 4 ones times 5 tens, which is the same thing as 50, right? 5 times 10 is going to equal 200. So we're up to the hundreds, which is the same thing as 2 times 100 plus 0 times 10. Right? Because the smallest thing we can get when we multiply ones and tens is going to be tens, and then the biggest thing we can get is hundreds. So we have 2 hundreds. Yeah, so 0 tens and 2 hundreds. And this, I'm just writing it out to make sure we understand what's going on, what's happening with the place value, but we'll just do that for this column, and then the rest we'll do a little more shorthand. So now we have 4 times 6. 4 times 6 for this square down here. Oh, sorry, I didn't make it pink. 4 times 6 is going to equal, what does 4 times 6 equal? It equals 24. So it equals 24, which is the same thing as 2 tens plus 4 ones. Sweet, so we have 4 ones, 4 down here, and then carry the 2 to the tens place. Sweet. So the reason I multiply all this out is just to kind of reinforce that these are going to be the colors that show up, right? But in reality, we can also just go into the individual box. So we can say 2 times 2 is 4 with 0 to carry over. 2 times 5 is 10. So that gives us 0, carry the 1. 2 times 6 to get this box is 12. So that gives us 2, carry the 1. 1 times 2 is 2. with nothing to carry over. And again, if you're like, oh, why is she writing this 2 in blue when we're multiplying 2 oranges together, right? Well, 2 oranges each represent 100 value. So 100 times 100 is going to be that 10,000. So that's why I write that, the 2 in blue. Because we have hundreds times hundreds is 10,000s. Just to reinforce that idea. So 1 times 5 is 5 with a 0 to carry over. 1 times 6 is 6 with a 0 to carry over. And again, the 6 is in orange because we have hundreds times ones is hundreds, and we didn't have anything to carry over. So now we have this pretty little rainbow square with a lot of numbers. So now each box represents its own multiplication, and the color represents its place value. So look at that again, the place values all line up along these diagonals. And we talked about why each place value is what it is. So we can say, okay, let's add up all the digits in here that represent the ones place. Well, it's just this 4 down here. And then let's add up the tens place. So 2 plus 2 is 4, plus the 0, but that doesn't really do anything for us. And then we have this long orange line, so we have 8 plus 2 is 10, plus 0 is still 10, plus 1 is 11, plus 6 is 17. So I'm going to put a 7 down here, and then carry a 1 into our next place up. And again, if you're like, Miss Kunert, why the heck, what is this? Why did I do this here? Well, here, let's write it out just to see. So we are going to have 800 plus 200 plus 0, so I'm not going to write that one down, plus 100 plus 600. And now I'll go right in the numbers. So we have 800 plus 200 plus 0, plus 100 plus 600. So this is the addition that we just did. When we do the addition down the diagonal, this is what we're really doing. We're doing the place value and writing it all out. So the zeros obviously just add to zeros. And then we got 17, so that's 1700. So 1700 looks like 1,700. Well, this diagonal is just for the hundreds. So we have 700, and then we have to put that 1,000 into the next addition we do when we add up all the thousands together. So now let's add up all the thousands. We have 0 plus 4 is 4, plus 1 is 5, plus 5 is 10, plus another 1 is 11. So now I have 11,000. So that's the same as 1,000, and then carry over the 10,000. And again, we could write all this out. If this is 4,000 plus 1,000 plus 5,000 plus 1,000 is 11,000, which puts that 1 in the next place above. So now we can add the next diagonal. So we have 0 plus 2 is 2, plus 0, still 2, plus 1 is 3, and then we have 0 for this one. So now we've put in the hard work, we've put in all of our effort, and now what is our final answer? It's going to be 3, 1, 7, find my right color for it, 7, 4, 4. And if you want some practice saying that, it's going to be 31,744. So awesome. And again, you're like, Miss Kunert, what the heck? Like, this took a long time. Why do we do it this way? Well, we're doing the same thing this way as we do when we do it our shorthand way. This way, again, we're just keeping track of place values, knowing what's actually going on, what each digit actually represents, and how we can do it that way. So now I'll show you how it is pretty much the same thing when you do it the shorthand way. So we'll have 1, 2, 4 times 256. Awesome. So first, we do 6 times 4 is 24. So put the 4 down here, and then carry the 2, right? And that just means we're going to add a 2 to the tens place up here. So it's almost like we're doing this little addition while we're going. So we have 6 times 4 is 24. 4, carry the 2. 6 times 2 is 12. Plus that 2 is 14. So then we have a 4, carry the 1. 6 times 1 is 6, plus 1 is 7. Sweet. And you're saying, where did we get the 744? Well, 6 times 4 is 24. 6 times 4 is 24. Oh, look, that's right there. That's so cool, that box. 6 times 2, we have our 6 times 2 is 12. And then we have the plus 2 right here, right? Gives us that 4. And then 6 times 1 over here. 6 times 1 is 6. Plus 1. Plus 1 is right here. That 1 that we carried over is 7. So we're pretty much, when we looked at 6, this row, we're doing 6 times 124. So we're basically just doing this bottom right here and adding them all together. So we did the 6 times 4 is this, 6 times 2 is this box, 6 times 1 is this box, and then we did the addition as we were carrying over, right? So we have the 447. So now we'll continue, and the reason we put this 0 here, that we all know just kind of to do, is because now we're going to be looking at the 5 to multiply, right? And the 5's in the tens place. So the smallest possible place value we can get is the tens times the ones, which is the tens. There's no way for us to get back to the ones by multiplying 10 times something. There's no way to get back to something that's just in the ones place. So then we do 5 times 4 is 20. So that's a 0. 5 times 4 is 20, 0, carry the 2. Here, we'll just cross this out, add another 2 up here. So 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. 2, carry the 1. And then 5 times 1 is 5, plus 1 is 6. Okay, so now let's see where our 620 is in our lattice. So here we have 5 times 124. So if we just look at this part of the lattice, right, we have the 2 in the tens place, 5 plus 1, or sorry, 2 in the hundreds place. 5 plus 1 is green, which is the thousands, and then 0 in the 10,000s. So we have 2 in the 0 in the tens place, 2 in the hundreds, and then 5 plus 1 is 6 in the thousands. So now we're just looking at this middle portion when we do that in the algorithm. So next, now we're just going to focus on this 2, right? That's how we learned to do it. So the 2 is representing the hundreds place. So the smallest possible place value we can get is when we times the hundreds by the ones, which is still going to be on our hundreds. There's no way for us to get to tens or ones. So we just put zeros there because there's nothing that we can get there. So we do 2 times 4 is 8. 2 times 2 is 4. And the reason I do these colors, right, because it's 200 times 20, which would be 4,000. So that's why I put the 4 there. And then 2 times 1, which is just 2. And now again, where do we see this in our lattice multiplication? We just see it as that top row. So we're doing the 200 times 4 is 800. We see that right down here. 2 times 20 is our, or 200 times 20, I'm sorry, is our 4,000 right here. And then 200 times 100 is going to be our 20,000, which is right here. So now we have all of our rows again. And now we add, just the way we added up here, right? So you multiply and then you add. So we're seeing how these processes are really the same thing. So we have the 4 added down, the 4 added down here, 7 plus 2 plus 8, 10, 17, or 7. So write 17 and then 100 because we're in our orange. So 1700 means 1,700, so we can carry the 1. Added to 17, carry the 1, 6 plus 4 is 10, plus 1 is 11. And it's really 11,000, so we carry a 1 over. And then this adds to 3. And it looks like we got the same answer. So the reason we show you guys all these different ways is because, yeah, we got the same answer, right? So either way is totally good. But as you saw, this way is really just a shorthand for what we did over here. So when we do this, we're talking about place values and stuff in our, kind of in our mind and just doing it as we go. But here we can really lay it out, which will make it easier later on when we start doing addition and multiplication in base n. So in different bases that don't work as nicely as the tens, we'll know how to multiply. So this is a really good way to do it. You can also do it this way, but the goal is for you guys to know that you're doing the same thing either way, right? Both ways we're keeping track of place values and multiplying based on our place value, based on our base 10. So I'm so glad you guys stayed with me for this lesson. Thank you so much for listening, and I'll talk to you guys soon. Bye.